Okay, today we're talking about parametric integration and how to remember what to do. So when we integrate normally, we find this one out. And the reason for that is we're usually finding out sort of the y value, if you like, how tall the different parts are on the function. And dx, think of dx a little bit sort of like the width of the rectangles. Okay, think of integration as these rectangles being infinitesimally small and there being, sort of lots of them all added together. Okay, now when we do this, how do we normally do this? Well, it might have the letter y here, but in reality, don't we normally say y equals x squared, and we actually sort of sub that in, don't we? So we often see things like this. That's when we know when we're ready to integrate. The thing that it's all in terms of, we see that we're integrating with respect to that. So that's just to kind of help you with a little bit of background to explain how we're going to do our parametric integration. So we start with the idea that we're integrating. We're finding the area under the curve the same as we always do. Now this is the way I remember it. I remember that when we're doing parametrics, it's in terms of t. So I add on a dt on the end, and then I think about what I've got here. And unfortunately, it doesn't really give you the same value as y dx, if you like. So once I've put this on here as my first part here, the next part of my reasoning is what do I need to add to make it work, if you will. So I put this part on here to show that overall it's giving me the same result as y dx being integrated. Well, that is the format that we want to use, okay? And you can sort of think of this part here as making the notation all okay. And these parts here in the middle, so you're going to have one part and two parts, these will all need to be in terms of t. A bit like when we were over here, everything before had to be in terms of the thing afterwards. So this is how we're going to sort of go about the question. What does it mean for us? Well, it means for us that we need to substitute in the right pieces here. So y, well, y is actually in terms of t already, so that's pretty much ready to go. So that's going to be 2t plus 3, so that's pretty good. dx dt, well, dx dt, this requires some extra work. We need to go from this one, and we need to make sure we've got dx dt. So that's going to require differentiating that equation that we've got at the top there. So that will just be 2t. So now I have sort of part 1 and part 2 here and here. And I'm ready to integrate it with respect to t. I'm going to multiply things out, so that will be 4t squared plus 6t. And now we just integrate it. Everything so far is just about setting up ready. So let's go over here. We're going to do t cubed, 4/3 of that, plus, let's do 3t squared. And this was an indefinite integral, so plus c. Okay, so that's kind of how I remember the format of how to set things up for parametric integration.